Hello folks, so today let's do a very important problem. It's called sorted array. We know there are a lot of different methods to sort an array. So here we will introduce the most the two methods that are most frequently being interviewed. The first one is called quicksort, and the second one is called merge sort. So in quicksort, in quicksort, we do the first thing we do is we do a partition. So basically we do a partition function. So step one is to do a partition function so that the total array is sorted. Sort in whole. That's step one. Then step two is then sort separately. So in order to do that, so we first use partition function to sort in whole. And the partition function returns the position or the pivot position where on the left of the position all the values are less or equals than the pivot position number, while on the right is larger. And then we use the pivot position and sort the left and right part of the position. So let's try to implement that. So self dot quicksort -1 and return nums. Define. Firstly, let's do a partition function. Self let's say array I j. So this partition function do two things. First thing is to sort the array by pivot value. So in the left, all the values will be less than pivot value, while on the right, all the values will be larger than pivot value. And the second thing it does is to return the pivot position, so that we can use it to partition partition the array. So firstly, we choose the pivot value as the value at position I. Then while I minus j, and an array j is larger or equals than the pivot value, then j should minus equals 1, then array I equals array j. Note that we should we should renew array I first instead of array j, because array I has already been stored, temporarily stored in private value. Okay, that's why we renew array I first, and we renew array j, and array I that's equals then private value I plus equals 1, array j equals array I. And since we changed the array I, here, so we should put the array I to be private value again. So in that way, this array has been sorted, where on the left all values are less than private value, on the right all values are larger than private value. Then we return, the second thing is we need to return the index or the private position I. Okay, quick sort. Nums start and if start larger or equals to end, then return. This is the exit of the recursion. So for quick sort, we sort in whole first, so we do partition sort first. Private position equals the partition array. Let's just do array start end. So we sort as a whole first, then we sort separately based on the private position we got. So self.quick sort array start private position self.quick sort array private position plus 1, and that's it. Let's try to run the code. Looks good. Okay, looks good. So this is method 1, which is called quick sort. In quick sort, we sort the array as a whole first and then sort separately. So we sort as a whole by using the partition function. In the partition function, the partition function do two things. One is to sort the array as a whole, and the other another function is to return the private position. And then we use the private position and sort the left and the right part of the position. So that is quick sort. Now let's do merge sort. Merge sort is a very good example of divide and conquer, or divide and merge. So in merge sort, we firstly sort separately First we find the middle. Find the middle point. Middle. Then sort the left and right separately. Then sort in a whole, or we say merge. Okay, so let's try to implement the merge sort. Self dot merge sort nums, return nums, define merge sort self nums, return nums, return the sorted nums, or we just use array. That's one less letter to write. Okay, so as I said, the first thing to do is to divide. So that's a divide and conquer algorithm. So we divide first. So that is we need to find the exit of the recursion. So the exit of recursion is if not array, return length equals length of array, if length equals 1, return should return array. Yes, or here also return array. So the first step is to divide. So we say left array equals self dot merge sort array. Yeah, we need to find the middle first. Middle equals length. Just use the middle of the array. Right, array equals self dot merge sort array middle. No. This one does not include middle, but this one includes middle, so it's fine. So the second step is conquer or merge. Divide is to sort as a whole, sort separately, and merge is to sort as a whole. Okay, so how to merge? We use 3 pointers, AJK, I less than length, j less than length of array. If array I is less than array j, then that means left is that means the left is less than the right. Wait, not array. Left array I is less than right array j. Then we should put left array to the array. Okay. Right array, or we just say else array, then array k equals right array j plus equals 1. In the case k should plus equals 1. Okay. After this, since we were using while I less than the length of left and j less than the length of right, there could be a case where I is not equals to length of array, so we should put that into, we should merge the left array to the array then. So while I less than left array k equals left array I plus equals 1, k plus equals 1. The same goes for right. Okay, we should return the sorted array. So that's merge sort. Let's run this code. Good, looks good, should be fine. Okay, so the runtime is 400 milliseconds. Let's see what's the runtime for the previous quicksort. That was faster, 300 milliseconds. So quicksort is a little faster. In average, quicksort is the same time complexity, which is O n times log n. But in reality, quicksort is normally a little bit faster than the merge sort. Also, quicksort doesn't need extra space, but merge sort needs extra space. So I think quicksort is more widely used in reality, but the divide and conquer method used in merge sort is very important, and we should definitely learn how to use it. So that's the video for today. Thank you very much for watching. Bye bye.